Okay, so for question 7, we're given the curve y equals to bx squared plus 3 over x plus a, and we're told this curve has asymptotes x equals to 1 and y equals to x plus 1. First thing we have to do is find the values of a and b. The value of a is quite easy because we recognize we've got a horizontal asymptote x equals to 1. So for x equals to 1 to be a horizontal asymptote, x plus a must equal to 0 when x equals to 1. So for that to happen, we need a equals to minus 1. To find the second one, I don't have to do long division. You could see from the very first step of long division that when I divide through, I'm going to get a bx term, and that means that because my asymptote here is 1x plus 1, b must be 1. However, that may not be immediately obvious, so let's just go through the long way as well. We're looking at x minus 1 divides bx squared plus 0x plus 3. So the first term I multiply is bx to get minus bx minus bx squared minus bx, and that will give me minus minus is plus, so this will give me bx plus 3. And so the next term I have to multiply by is b, so I get minus bx minus b, and so that gives me 3 plus b. So y is actually equal to bx plus b plus 3 plus b over x minus 1. Okay, so far so good. What does that mean? Well, we know from the asymptote, as x tends towards plus minus infinity, y is going to tend towards x plus 1. But if we look at this, we also know that y is going to tend towards this bx term. It will go as bx. B is going to stay the same, but as x gets very, very large or very, very small, this last term tends towards 0. So just by inspection, you can see, therefore, b has to be 1. Okay, part 2 wants us to sketch a curve of b, and we need to know, indicate clearly any axial intercepts, asymptotes, and stationary points. So to find, we know the asymptotes already, x equals to 1 and y equals to x plus 1. What about axial intercepts? So we just try what happens when x equals to 0. That means that y is equal to 0 plus 1 plus 4 over 0 minus 1 is equal to minus 3. Yep. And when y equals to 0, that means that I've got x squared 0 equals to x squared plus 3 over, sorry, it should be plus, over x minus 1 implies that x equals to minus 3. So those are my axial intercepts, and then the last thing I'd need to look at is stationary points. So to do that, I'm going to differentiate what is dy by dx. To differentiate, I'm going to use this form of y, x plus 1 plus 4 over x minus 1. So the x just goes to 1, the 1 disappears, and then you get minus 4 over x minus 1 squared. And I'm going to set that equal to 0 for max, or for maxima and minima. So if I solve that, that's the same thing as solving, move this side over, I'd get 1 is equal to 4 over x minus 1 squared. So x minus 1 squared is equal to 4, x minus 1 is equal to plus or minus 2, x is equal to 3, or x equals to minus 1. So if x equals to 3, if x equals to 3, I get y is equal to 9 plus 3 is 12 divided by 3 minus 1, which is 2, so I'd get y equals to 6. And if x equals to minus 1, I would get 1 plus 3, which is 4, over minus 1, which is minus 2. So I would get y equals to minus 2. So that's all the information I need. I can now start drawing it. You're going to have to excuse me, I'm sorry, because this is not the easiest piece of equipment to draw on. So I'll do my best, but no promises. It's the y-axis. This is my x-axis. And I recall, okay, I've got my first asymptote at x equals to 1. And I've got a line y equals to x plus 1. Right, and I've got an x-intercept at minus 3. Hold on, something doesn't seem right, because if I go out there I won't have any turning points. It should be in here. So let me just look at my x-intercepts again. Ah, okay. Sorry, okay, back up here. This should have been x squared is minus 3, which of course I'm going to reject. So there are no x-intercepts. Okay, sorry about that. So again, please take note. No x-intercept. So y equals to 0 means x squared has to be minus 3. That's impossible. So no x-intercept. So just the y-intercept at 0 minus 3. We're down here somewhere. And then I know I've got my so I'll label that. Sorry, that's 0 minus 3. Then I should indicate also my turning points, which is minus 1, minus 2. So minus 1, minus 2. And at 3, 6. So that's probably up here somewhere. So what's my curve going to look like? It will be a hyperbola, so I know it's going to look something like this. Sorry, that part up there is terrible. Let me just move my 3 minus 6, sorry. It won't quite be proportional anymore, but I think it'll be easier to see what I'm doing. 3, 6, sorry, not 3 minus 6. Yep. Okay, so the graph should look something like that. Okay, so the last part of this question asks me to prove an inequality. It wants me to hence solve the inequality bx squared plus 3 over x plus a less than or equal to 2. Or in other words, now that I know the values of a and b, x squared plus 3 over x minus 1 is less than or equal to 2. So absolute value means this is the same thing as solving this inequality. Minus 2 is less than or equal to x squared plus 3 over x minus 1 less than or equal to minus 2. So what I'm going to do is I'm going to draw in my two lines. So this is where this line here is the line y equals to 2, and this line here is the line y equals to minus 2. And you can see there's only one point where that lies inside these two curves. So actually mostly there's nothing. There's only one point that even comes anywhere near it and lies right on the boundary, and that's the maximum point that you've seen here, the point x equals to minus 1, y equals to 2. So therefore the only answer from the graph x equals to minus 1, because it's the only point inside that region. And that is the end of question 7.